Alright, okay, as promised, I'm going to work up some of this data. One of you lucky students, I've stolen your data and I'm going to work with yours. I'm not going to tell you who it is though. But first let's do a once over kind of what happened in this lab. So we took some of that fertilizer. Notice it's blue, okay? And then what we ended up doing, we reacted it with a base, which in our case it was ammonia hydroxide and magnesium sulfate. Now there's a phosphorus compound in the fertilizer that when you throw it in with a base and then the magnesium, you end up forming this big gloppy solid magnesium ammonium phosphate hexahydrate. From here on out, I'm referring it to as just the salt. Now over here to help me out, I went ahead and looked up the molar masses of both the salt, which is 245.4. I'm going to need phosphorus, which is 30.97, and diphosphorus pentoxide, which is 141.9. Now the reason we need those is because the whole point of this, we're trying to figure out what is the percent P2O5 in our plant food. It reported that it was 20% P2O5. So since we isolated this solid, we can figure out how much phosphorus is in the solid. Using the stoichiometry, we can extrapolate back. If this is how much phosphorus in the solid, then that's how much phosphorus must have been in the fertilizer. And so then we can figure out the percent phosphorus in the fertilizer. And then once we get the percent phosphorus of fertilizer in the fertilizer, we can get the percent P2O5 that it came from. And that's when we're going to compare these to our answer and the box answer. And remember, this is comparing for accuracy. We're also going to do a comparison of how precise all of our measurements, because remember, you did this 3 times over. And we're going to do something called standard deviation in order to tell us how close our results were to each other. Okay, so let's get started. You're going to need a calculator. And again, I'm going to keep these molar masses out to the side. So let's, by the way, in the lab, it actually goes through the calculations. It explains it pretty well, especially the standard deviation, but I'm going to go over it once. Remember, you do have your pre-lab problems, which after I teach how to do standard deviation, you should be able to get through those pretty well, and then the rest of it comes from the reading. Okay, so I'm moving over to this page where I have data, and you should have data too. Now, of course, in order to get this number, you took this number minus that number. That's why mine are blank. I just took the actual stuff that I needed. Okay, so it's asking for the mass of phosphorus in the original sample. So our first thing we're going to do is this is coming from the salt. So we need to figure out how much of P is in the salt. So what I'll do is I'm going to show you step by step through one of them, and then I'm just going to kind of fill in the rest of the answers. And you guys can kind of, and then you can kind of stop it, do your work, and then move on. Okay, mass of phosphorus. Okay, so we have, this is what our salt weighs. Our salt weighs 2.25 grams of the salt. Now we need to get to, again, if we're going to compare of how much, it's a 1-to-1 ratio, we need to get to moles. And so how do we go from grams to moles? Yes, the first thing we have to do is divide by the molar mass. So again, it's 245.4 grams per mole. And if you end up doing that, and again, you use your numbers, not mine. My calculator may not work. Luckily, I've already kind of like done the work over here to the side. I think I did. You end up getting 0.00873 moles. So that's the first step, divide by the molar mass of the salt. Second step, and this is of course the salt. Now we have to think, well, how many moles of phosphorus are in the salt? Well, if we look over here, it's 1 phosphorus for every 1 molecule of salt. So essentially we're just going to multiply 1 over 1, which is the same. But that makes it so that we have 0.00873 moles of phosphorus, because again, there's 1 phosphorus for every molecule of the salt. So now we have phosphorus. We want to get to grams of phosphorus. How do we go from moles to grams? We're going to multiply by the molar mass, which again I have written down over here, 30.97. Okay, so multiply by the molar mass. So go ahead and do your multiplication. Mine ends up being, I get 0.270 grams of phosphorus. Okay. Now, but now we want to get it to, okay, so this is our mass. So I'm going to put this right up here, 0.270 grams of phosphorus. And you're going to go ahead and do that exact same process for your other 2, and you're going to get your mass of phosphorus in each one of those. So you can go ahead and pause it now and get that done, so then you have some stuff to work with.